When we talk about speeds with respect to carding, we are primarily talking about 1, the surface speed of the rolls, and 2, the speed of the production line. The speed relationships in a card are some of the most difficult adjustments to make. There are very few rules to go by. This is an area that involves trial and error and experimentation to get it right. By getting it right, I mean making the best quality webs out of the card for a given fiber and production speed. Let's begin by discussing the various speeds we can change on a card and how a card handles the pounds of fiber we put through it. Certain rolls in a card revolve at a fixed speed. Other rolls are variable in speed, but once you set them, you usually leave them alone. Finally, there are rolls that change speed as the entire production line changes speed. Older cards usually have main cylinders that are run by fixed speed motors. Since the breast and liquor in are often driven by belts connected to the main cylinder, these rolls are fixed speed also. However, the pulley driving the main can be changed, though that requires shutting down the card. Newer cards have variable speed drives on the main cylinder, so the main can be changed on the fly. However, the breast and liquor in are still often tied to the main cylinder, and they will change speed with it. On older cards, strippers are driven from the main cylinder, so they run at a fixed speed. On newer cards, they have their own motor and can be changed on the fly. On some older cards, the workers are tied in with the doffers and vary in speed as the line varies. On newer cards, the workers run at a constant speed but have their own motor, and the speed can be changed on the fly. The doffers on all cards, whether they have their own motors or not, vary in speed with the production line. They have to, or else the web would break or pile up coming out of the card. The takeoff rolls vary in speed with the doffers. The feed rolls at the back of the card vary in speed with the production line. They may have their own motor, or they may be mechanically tied into the production line. Thus, as the line speeds up, the feed rolls feed more fiber into the card. Often the feed rolls have a device tied into a system that measures the amount of fiber coming into the card. Some of these systems actually weigh the feed bat between the card and the feed chute, and others shoot an X-ray through the feed bat to determine the density of the bat. These devices then send a signal to the feed roll motor to speed up or slow down slightly to maintain a very consistent amount of fiber going into the card. Okay, let's recap what we just discussed as we look at these graphics of the card rolls. Starting at the feed end of the card, the feed rolls and cleaner rolls are tied together mechanically, and they are driven from a single variable speed motor. All the rolls from the liquor in through the main cylinder are tied together mechanically. That means that the speed relationship between these rolls cannot change. However, all these rolls can change in speed together because they are driven mechanically from the main cylinder, and the main cylinder has a variable speed motor. The workers on the main cylinder are all tied together and run off a variable speed motor, as do the strippers on the main. They have their own motor. Each doffer has a variable speed motor, and each takeoff has a variable speed motor. When a non-woven line is making product, the card has usually been adjusted for optimum speeds for the various rolls. The feed rolls speed up and slow down with the production line speed to keep a steady flow of fiber into the card. The main cylinder and all the rolls driven from it run at a constant speed. It does not vary with line speed. The workers and strippers, once adjusted for optimum web quality, run at a constant speed and do not vary with the line speed. The doffers do vary in speed with the production line, as do the takeoff rolls. Thus we see that the rolls feeding fiber to the card and the rolls taking fiber out of the card change speed as the nonwoven line speeds up and slows. All the rolls in the middle of the card run at a constant speed unless minor adjustments are made to them to improve the quality of the webs. Since carding is basically a function of how many wire points the fiber comes in contact with, you may correctly surmise that the amount of carding when the nonwoven line is running at idle speed is much greater than the amount of carding of the fiber at line production speed. Because of this, we try to minimize the amount of time the card is running at idle speed. We also work to optimize the quality of the webs at production speeds by selecting proper wire, adjusting settings, and adjusting. Cards have been greatly improved over the years, and the newest cards do a much better job of producing quality webs over a wider range of line speeds. I need to point out that there are two methods of measuring speeds for a card. Rotational speed measures how fast the rolls revolve. This speed is expressed as revolutions per minute. Rotational speed does not take into account the diameter of the roll. Linear speed, usually measured in meters per minute, does take into account the size of a roll. Linear speed measures how far a point on the surface of the roll moves in a minute. Thus, if two rolls were turning at 100 RPMs and one roll had a diameter 4 times that of the other roll, the surface speed of the bigger roll would be 4 times that of the smaller roll. Most readouts for card rolls on control panels read out the linear speed in meters per minute. So what are the critical components that need their speeds adjusted for a card? What speeds would you need to change when changing fiber types or fiber denier? The three main ones are main cylinder speed, speed of the workers on the main cylinder, and speed of the strippers on the main cylinder. These are the three primary components involved in carding the fiber. The speed adjustments made to these rolls has a lot to do with how the teeth actually grab the fibers. Trial and error speed experimentation with your particular fibers will enable you to obtain the best quality webs. Cards are used to make webs of fiber for many different products. Knowing what speed settings to use for the various types of fiber fed into the card is critical for making quality finished product and for maximizing the number of pounds of fiber per hour that the card can process. Here's a recap. 1. Speed refers to how fast the rolls in the card are moving. 2. Rotational speed is measured in revolutions per minute. Surface speed is measured in meters per minute. 3. The input and output rolls follow the line speed of the entire nonwoven line. 4. The rolls in the middle of the card run at a constant speed, but can be adjusted to account for changes in fiber types processed by the card. 5. You will have to experiment with your card to optimize the speeds for each fiber type and throughput. It is tedious work, but it will optimize your quality. Well done! You have completed Chapter 5. Please return to the main menu and select the quiz for Chapter 5.